Welcome back to Enzyme Inhibition. This time, we will discuss product inhibition and see how we can use product inhibition to determine whether a sequential BiBi reaction is ordered or random. To get the most out of the videos, I recommend that you watch them in order. This is a reminder that this presentation is Dr. Johnson's intellectual property. Let's consider an enzymatic reaction. Normally, when we set up reactions to measure the reaction rate, we are careful to make sure that we are looking at initial reaction rates, which means that there is no product in the reaction mixture to begin with. However, in a reaction mixture that contains both substrate and product, both could bind to the active site. In other words, they are competing for the active site. If you had a way to measure just the forward reaction, you would find that the product is a competitive inhibitor. Let's take this idea to the more complex system with two substrates and two products. You may recall that when we discussed sequential BiBi reactions, we saw that there were two possibilities for substrate binding, ordered and random. In practice, it can be really difficult to tell them apart based just on their Lineweaver brick plots, so we would follow up the finding that a ternary complex is formed with some additional studies. Product inhibition studies are traditionally the best known of these. The idea here is that if one of the products is added to the reaction, it will slow down the reaction. Furthermore, the type of inhibition will depend on what can bind to the free enzyme. In the case of the ordered sequential binding mechanism, only A and product Q can bind to the free enzyme. Therefore, Q will compete with A for the active site, so the behavior we observe is that Q is a competitive inhibitor with regards to A. The other three product-substrate combinations all exhibit mixed inhibition. For the random sequential binding mechanism, where any of the substrates and products can bind to the free enzyme, the QA product-substrate inhibition pair will show competitive inhibition, as will the PB product-substrate pair. In practice, the other two combinations also exhibit competitive inhibition. Before we leave this topic, you should know that there are some further divisions of sequential binding mechanisms. We will not be discussing them here. Next time, we will look at enzyme inactivation.